right, our next speaker is Marcel Weiher. Is that right?
Yeah.
Weiher. Weiher.
Just like the Weiher.
Weiher.
Yeah.
Who is... Oh, okay. Oh, yeah. Beyond, he's going to take us beyond procedure calls. And since we all know that procedure calls are a requirement of all programming languages and are necessary and sufficient, he's going to explain to us why that's not true, I think, right?
Well, we'll see. The title of the talk is, and the paper is actually a riff on Mary Shaw's seminal paper, Procedure calls are the assembly language of module interconnect. Connectors deserve first-class status, and I see Mary Shaw is in the room with us, so no pressure. We'll see how much I've hashed things up. And my name is Marcel. Yeah, okay. I'm a post-career PhD student at HPI in Potsdam, working with Robert Hirschfeld and Marcel Taeumel. And well, we'll see. What I'm talking about is a programming language, an architecture-oriented programming language called Objective-S. It used to be called Objective Smalltalk, but that was too long, and it's still too long, and it's a bit of a joke, but anyway. Obviously it's a development that's based on Smalltalk, but it needs a little bit more because, I mean, in my career I've noticed that programming is just too low level, and it's too much work, and I think that software architecture is sort of one of the things that's missing, and one of the things that's missing is being able to actually express the architectures of our systems in the code. Instead, we have to write procedures that implement that architecture. And I think this has been, you know, I'm not the first person saying this. This has been said for a long time, and I think I might have had a crack at solving this. And the key is actually combining software architecture and metaprogramming, particularly of the style of metaprogramming that's in the art of metaobject protocol discussed there, where we take the object-oriented principles and apply those to the metaprogramming problem. So our metaprograms are also object-oriented frameworks, and the programming language comes out as the induced domain-specific language that is induced by the framework. And there's a little bit of an addition. The thing is implemented in Objective-C mostly, which, you know, it doesn't make it that different because Objective-C is just C and Smalltalk smashed together. But the key is I don't add these things to Smalltalk. I generalize from Smalltalk. Right? So because when we have components and connectors, the other things that we tend to have in programming, for example, object and messages, well, that's a component and connector. Same with, you know, algorithms and data structures, pipes and filters, files and paths, resources and URLs. So basically, Objective-S takes the two components we saw before, the software architecture component, which is the conceptual framework, and then the meta-object programming system, that's the implementation framework, and then builds everything else on top of that as specializations. And of course, one thing we learned from Smalltalk is that the implementation hierarchy does not have to be the same thing as the conceptual hierarchy. So in terms of implementation, we have the procedures. We're good. It's all built from procedures. And the way to get there is basically when we saw, you know, when software architecture research was done, there was a lot of field work actually in terms of what, you know, how are we actually building these systems? What are the connectors in the wild? And one of the papers that I used is towards the taxonomy of software connectors, and there's quite a bit there, right? And because it's a taxonomy, it's actually structured, so that's really useful. And what we see is in the top left corner, we see sort of some of the columns, there's a type, and when we see the types, and there's values, right? So we have very few types, and then we have lots of values for those types. And that's really actually essential, right? Because there's lots of complexity over on the right, and there's actually only a few things on the left. And we can then just ignore the entire rest and actually scrunch it down a little bit and then just plot those in 2 dimensions. So we have a subset of the types running vertically, and then on the right-hand side we have variants of those particular types. And that's a really interesting table, I find, because there is a lot of complexity in software and how we build software, and it just reduces away. And if we look at this table right, we can see that the problem of adding software architectural description may actually be simpler than we thought, because we don't really have to add anything. It's already there. We just have to look at it differently, because the variants that we have on the right are actually things that are usually in our programming languages, just not in every one of them. We have particular examples that are in particular programming languages. For example, some programming languages have procedure calls. Other programming languages have synchronous message sends. Other programming languages have asynchronous message sends, and so on and so forth. And so the problem of software architecture becomes actually expressing software architecture in code becomes the problem of variation of programming languages. And that's what we have metaobject programming for. And so we don't really have to add anything new. We have to just take languages that we already have and make those polymorphic in a better way than we do before. And in the other direction, we never really had a good model, I think, for how do we do metaprogramming. We have all sorts of models, but syntactic macros or the metaobject protocol of clause was pretty close, but then that was fairly tightly defined. It's like we can make variations of object-oriented languages, but nothing really that spans. And I think so, in my opinion, these 2 areas actually need each other. So we get better metaprogramming through software architecture, and we get better software architecture through metaprogramming. And so that's the approach, basically. That's the core idea. And then we just start doing things. Like we had a metaobject protocol, right? And it's in each case, it's in Smalltalk syntax, and it's not the complete metaobject protocol, but it's a sort of an extract. So for the procedure call, we have the send. We send a message, and we can have different types of metaobject protocols messages there. Send would be a synchronous message, and we can have an asynchronous message, and so on and so forth. For data access, it's basically the set the value, get the value. For data flow is just here's some value, some object, write it to somewhere, and that's really it. And once you have that, we can actually then support that at the language level. And so and have syntax for easily accessing anything that conforms to the particular metaobject protocol. So anything that somehow can be sent a message, we can use message sending syntax. Anything that can has data that we can access and we can either get or put, well, we have syntax for that. Anything that we can just shove data at, well, we have syntax for that. And there's sort of a hopefully a pull effect that once you have these 2 things defined, it becomes very beneficial to actually conform to that particular metaobject protocol if you have something that's sort of in that shape, because then you get language access. And that makes things very simple for users to use your stuff. And of course, since it's no longer 1980, we can use left arrows instead of weird combinations. And yeah, and so the next step is, since all these we've made all these different kinds of things conform to the same protocol, it now becomes not necessarily super easy, but certainly straightforward to connect them together, because they all have the same shape. And once things have the same shape, we can just keep plugging them together. And also, we don't really have to introduce much special syntax to do that, because there's just one action. Please plug these two things together. So we can just take the right arrow, which works for most of these, except for the procedure calls or the message sends, because we kind of already have that. It's not really clear what we can add to that, although there may be some things we can add to that. So, and once we have all that, the purpose, of course, is, can we actually make, or the question is, can we make different architectural styles as convenient as currently we have, procedure calls, message sending? Because that's kind of where we want to be, because right now, the only architectural style that has good support in convenient support is procedure calls, message sends. And so you can have any color as long as it's black. Well, and you have a choice. You can either make your system conform to that, or you can make a good architecture, and then you have all sorts of indirection in your system that you cannot get rid of. And so the first one, well, that's a procedure call, so we don't need to do that much. Of course, except that, of course, we have the special case that the procedure call architectural style is also what we use to implement. But we do a little bit. We have higher order messaging. That's a paper from DLS, I think, 2002 or something. And basically, it's a message that takes a message as an argument. And the prefix message controls how your messaging works, how the messages are routed. And some examples of that are, we have a standard hello world, standard out println hello world, and then we can control how the message gets routed. For example, here we have the message gets sent with multiple arguments. That's the first one. So we have number of messages sent can be changed. We can have this number also in the receiver or in arguments. It doesn't really matter. We can also control time or synchrony. Normal message sending is synchronous. We say, well, maybe we want it asynchronous, or then we just have a prefix message that says, well, please send this asynchronously. Or we say we want to send it after a second. That's actually used in the, what was it called? I forget. Kannst du mir kurz helfen? That's the system that Andreas was working on. Okay. Yeah. And we can also encode some more complex patterns, right? For example, if response just says, well, if the receiver understands this message, then send it, otherwise don't. Nee, nicht tweak, dieses Multi-Agentensystem, distributed. Croquet system. Yeah, sorry. Brain fart. And actually, there's some further architectural patterns that you can encode, but slides. So we got that. Data access is actually one of the more interesting ones I found, and it's also the one where a lot of this was started. Back in 2003 ish time frame, I was working for the BBC, and we had a website system, and I decided I wanted to see if we could, in the rewrite of that system, just mirror the external structure internally in the system. And that turned out really well, and then I wrote it up as in-process REST. And of course, REST is a architectural style that, whether you like it or not, it certainly seems to have worked somehow. We have a fairly large distributed system that's built on it. And we're using it more and more to also structure systems. I mean, for example, microservices are a way of structuring systems using REST architectural style, except all of them then have this packaging mismatch of you must actually distribute the system. Now, wouldn't it be nice if we didn't have to distribute the system in order to do that? And the components to accomplish this are polymorphic identifiers. Basically, you can use URIs as the identifiers in your code. Storage combinators that resolve this and are also very pluggable, very composable, because the REST interface is just a couple of verbs, and that makes things composable. And then you get first-class references out of that, which I'm actually not going to go into. So polymorphic identifiers, the idea here is we have a lot, when we access data, unless it's the built-in language kind of access, we can, if it's that, we can just use the name, yoo-hoo. But if it's anything else, we have to wrap it in a procedure. And so we get this great variety of procedures that all do exactly the same thing, just for a different type of access. And well, you don't really have to do that. If you have URIs in your system, they can all look the same, except for the bun part that says, well, please look here. And I think you can see that in the two right, the rightmost columns. And of course, it's important that this doesn't just work for built-in domains. You can always you can define your own, and actually that's where I have found this to be most useful. So basically, for your own domain, you say, I want a certain kind of way to access this. I make a store that can handle that access, and I define a URI pattern that accesses that, and I plug that into my name. And of course, once again, these are composable. So for example, in Wunderlist, where I used this, this was the store hierarchy, right? And so all the ones that have arrows leading out are storage combinators. That means they're stores that take another store or several stores and combine them somehow. And what's wonderful is you can just plug things into that hierarchy and take them out. And for example, there's a keychain access right there, right? So there's a switcher that says, well, if this is sensitive data, put it in the keychain. And the rest of the system is none the wiser. It doesn't really have to know about this. And Hello World on the web, of course, obviously since it's in-process REST, web programming is kind of very natural. And so the first line is just, we have a dictionary that says, has the world value for the hello key, and then we just hook that up to a web server, and that will serve this onto the web. And so if you type the URL, if you give it a URL with wherever you post it, wherever you put the server, and hello, it'll return world. And the second one is more flexible. You give it the URL greet / and then your name, and it'll return hello and the name that you gave it as a parameter. And that's these are jet lag is really getting to me. Property paths, that's what I called them. So basically, you can a lot of programming languages these days have properties, and basically what these just do is extend them so you can have full paths. that you can specify. And one of the really nice things, as I said, is you can just switch things around. And for example, the previous example that we had of the fairly complex store hierarchy for Wunderlist, for testing purposes, we don't want that, right? We don't want the unit tests polluting our keychain, and we don't really necessarily want to go access disk. So replace it by that, right? And again, the rest of the system is none the wiser, because we just have its stuff in memory. And of course, when I showed you these more complex Wunderlist store, that was actually a lie. It actually looks like that. And again, during the development process, we could just plug things in and it would just work, and it's all in process. I asked one of my colleagues for the storage combinators papers, what he estimated what the benefit was in terms of development time, and he told me about 2x. So I put that in the paper, and it's like, okay, good. I met him a little later, and he said, when I told you 2x, that was a lie. I said, oh shit, what did I do? It was more like 10x. I just didn't think that number was believable. So that was data access, data flow. That's just very simple. Again, that's the super simple one, Unix pipes and filters. We all know and love, except that, of course, there's some issues when you actually want to reuse Unix pipes and filters from other systems, because you have to start processes, you have to serialize, deserialize the data, you have concurrency issues. But you get very concise programs. There's the famous Bentley's challenge, where John Bentley from the Programming Pearls, he challenged Don Knuth and Doug McElroy to do some word counting, I think, task. And Don Knuth had this wonderful 12-page, literate program, and it was just a beauty, right? And Doug McElroy had a 6-line shell script. And it was only 6 lines because he put each command on a separate line. Right? So you can get, it makes a difference. And the other example was Nile Jazeera from the STEPS project, right, where they did, I think, a rendering system, computer graphics rendering system in 400 lines of data flow, which is really impressive. But again, you also have these problems that very often you have this packaging mismatch. So my answer to that was polymorphic white streams, which I wrote up. There's a paper on that. And basically, it's object-based, so a bit like PowerShell. It's completely its default mechanism is completely passive. So you can add activity, you can add multiprocessing if you want to, but you don't need to. What makes it a little bit more magical is the double dispatch. And that's what the polymorphic white streams paper actually talks about most of the time. That it can decompose and recompose object graphs on the fly and combine that with stream processing. And one of the really cool things about data flow in terms of usefulness in larger systems is that because it's based on the data flow, not on the control flow, it's concurrency agnostic. So even though the basic system happens to be synchronous, adding asynchronous elements is easy, and it doesn't change the semantics of the composition much at all. It just changes exactly what happens when. And again, some examples. The first defines a filter. It's the greeter filter, and the little pipe symbol says that please make this a stream message. And yeah, it writes the hello with whatever you passed it in as an argument to the next filter. And the idea was, again, it's a convenience thing, and convenience is really important, as I think some of the previous presenters also rightfully noted. And therefore, defining a filter should not be much more strenuous and much more arduous than defining a method usually is. Because very often people want to use these alternative architecture styles because they should be better, but they're too complicated. to express in current systems, right? And then if you want to fill that right, then I stole that actually from C++, so yay C++. But since I already had all the arrows used up for other stuff that I thought were more important. Because, for example, right next there is the right arrow for just, we combine standard in, hook that up to the greeter, and then hook that up to standard out. And I think, that's an architecture, and I think it's pretty obvious what it does, and it's pretty concisely expressed. And again, the data flow architectural style seems to be extremely composable. What I've found is that it just really works extremely well as glue in all different parts of the system. Not so much by itself, but just hooking things up together. For example, the next one is just have a text field instead of standard in as the source, and you hook it up just the same. It doesn't really make a difference. And we have interop. Obviously, we have the interop with objects. We have interop with Unix pipes, and there's interop for the Al Jazeera system. I actually wanted to see if my idea of having these passive filters works in other contexts just as well, and it turns out, yes, it does. I replaced one of the filters in one of the Nile demos with one of my own, and it works quite nicely, and it should play, yes. So, yeah. And this was one of my stretch goals, was being able to implement data flow constraints basically within the system. Oh, I need to finish? Okay.
3 minutes.
Okay. Data flow constraints also work. Yeah. And one of the interesting things that came out of this work was that usually data flow and events are apparently considered very different architectural styles in terms of syntactic and language support. I found I could handle them using the same mechanisms. So internally, we have notification protocols that basically connect an event system to messages of classes. So you can just say, I have a class that implements a specific protocol, a specific interface, and then I can message that interface, that protocol, and it'll just message all the classes that implement that. And event buses work as you would expect, basically just like a filter. And those were the styles I was going to have a look at. And then just a quick note on how the connect works. I have polymorphic connection. So the first image is sort of the... so the arrow is not actually the connector. That's kind of weird. In the theory that I looked at, the way it works is the full model is you have a component. The component has a port. You connect the port to one of the roles of connector, and then you connect another role of that connector to the port of a component. Writing that out every time would be extremely arduous, and it turns out that most of the time you don't have to. And in fact, most of what in practice, when I use this, I find that the form at the bottom is the one I use the most. Because if I say these two components, I want them to be connected, the ports are obvious and the connector is also obvious. If they're not, you can go back and disambiguate it, but usually you don't have to, and that makes a huge difference in terms of convenience. So we got that, and basically we're back to the overall picture. There's a bit of outlook. There's lots of things that could be done. There's debugging that I think can work much, much better when you have a higher level model of your system, rather than having to recover what the system is doing in terms of your intention from the procedures you wrote to implement that system. Multi-program systems are very close, and I think will be really, really, really interesting. And of course, you want to do more connectors, more variants of the connectors. Okay, maybe we can do something about structure, definitions. Yep. And yep. That's it.
So I have one question. It seems to me, you know, I was thinking about the command query response architecture style, communication style. One thing that's kind of common that you might want to do is create projections for different contracts between things. And have you thought about ways of taking stuff and making projections as part of? So in essence, you know, it's not like I have the API with this type, but I want to be able to have support for generating projections as a programmer. Do you know what a data projection? Yeah.
I mean, I think that it's a slightly different area, right? But I mean, if there's some prediction from that's going on, I would like to probably express it as a maybe a different connector.
Yes, and that would be nice to be able to have some support for understanding the projections I need to do. That's what I'm saying at that level that you're talking about. And then another thought was, what about data mesh architectures these days, which are, you know, it's not simple connectors. It's anyway.
Yeah, I mean, so far this was getting the simple stuff done, and now, you know, here, that type, there's lots going on, and I think maybe when we have a start, you know, we can start adding stuff and do the really complex. Also, just larger aggregations. I haven't really done.
Yeah. Okay.
Right? But I think this might be the starting point for actually doing that.
Yeah, I think it's really cool, but I'm just asking for more, so I'm sorry.
Thank you. You know, please do stuff.
Hi. I was just wondering, are you at all familiar with sort of the modern JavaScript metaobject protocol since 2015?
Very little. I do know that I think sort of in some of this, I think the higher order messaging stuff got in there in a slightly different version.
Yeah, I mean, the basic idea behind it was in designing the language at that level. There was lots of weird things implementers were doing with special types of objects and had special semantics on field access or method invocation for special cases, particularly in like the DOM and such.
Yeah.
And these were things that couldn't be reproduced in JavaScript code. And so one of the design goals was to be able to self-host any of that sort of stuff. But it just occurs to me, I mean, it's another example now of a language with a fairly complete meta-object model, and it might have some utility in what you're looking at here as another thing to contrast it with.
What I've noticed is that, I mean, also Pharo has some specifics. Is they tend to, when they do data access meta-object protocols, they tend to be extremely field-specific, and that tends to be limiting, I think. Now, I think you can take this and plonk it on top of that. I'm not sure the other way works around as well.
Yeah.
Okay, thank you.
Okay.
Yeah.
So thank you for taking this on. I'm really happy to see how far you have pushed it. I have a small question and a large question. The small question is an example. In their paper on the specification of the A7, Parnas, Clements, and Weiss, focusing on separation of concerns, created an example of what they called a data banker model in which you could do a single kind of data access, and the information hiding mechanism would disguise whether that was a direct access from memory, a query from a sensor, a bunch of other things. I just wondered whether you're familiar with that example, and I'd be really interested to see how that example works out in your system, because they came at it from a very different standpoint, but it has a lot of the characteristics that you're after. although I think they may be moving them to a different level of abstraction. So it's hiding the underlying mechanism by which a piece of data is estimated or retrieved or fetched.
Yeah.
So I'll
Yeah.
just, I don't want to dwell on that if you haven't already thought about the example, but I'd commend it to your attention. The larger question is about the other assumptions that come along with the connector. So for example, in pipes and filters, one of the things that I always found perplexing about Unix was that there's no type checking on the streams. The filters do not come with a specification that says arbitrary text stream. I'm expecting a line break every 5,000 characters or less. This is really something else. That for me is a piece that's missing from pipes and filters, which is a further restriction on the combinations that are legal. Another example of a further restriction in pipes and filters is that if you want to do composition of function, that is, this filter computes F and that filter computes G, and you want to compute F of G, you can compose them, but you only get that assurance if there's no out-of-band communication between the filters. Have you thought about ways to incorporate this kind of additional constraint on the use of the connectors as part of the validation of the system as a whole?
Not much. Certainly type checking connections is very interesting. I know very little about type checking, and this was big enough as it was. I've barely managed it so far. But I think that's certainly one of the areas of useful future research. And I think having a language that we can actually concretely implement stuff with then makes it more interesting to now we can, what should we restrict? The other part is I've taken, of course, I also come from the sort of dynamically typed world where it's like, we don't care, it'll work itself out. On the other hand, there is a bit of, so for example, I heard some of Herb Sutter's talks on modernizing C++ recently, and one thing I found very interesting that he said was that good defaults matter a lot in actually practical safety, not theoretical safety, practical safety. And I think having, so I'm more of a pull and make a good offer to people to, okay, you have good tools, you have a great toolbox that is convenient to use for you to make good architecture. We're not going to do very much to slap you on the wrist if you got it wrong. That can be added, but we want to make it easy for you to make the right thing. Slide downwards to pit of success.
Right. Yeah, I agree with that. We used to say that there was a time when people were trying to design languages to prevent people from making mistakes. And a bunch of us took the other position that was impossible because creative programmers can make mistakes no matter what you do. You're better off trying to design a language in which it is easiest to do the good things, which is what you've just said. So thank you.
Yeah. Thank you very much.
All right. Thank everybody. The conversation can continue, but the session's officially over and lunch is starting.